Hello everyone, I hope that you are all doing well and you all had a great contest. Can you guys please confirm if you can hear me well without any issues? Hi, nice to meet you guys. How was today's contest? Nice. And as you can see, I have changed the background a little bit. We have more light. Oh, we have echo. Really? Echo? I unfortunately couldn't participate in the contest today. I was in the university from the morning and I just recently could come home. In the weekends, I usually am outside, and especially most of the times I'm in the university. And I just got home. Oh, seriously, we have echo? How? Everything is close here. Every voice. That's weird. How is that possible? Like sound in plastic pipe. Is it understandable? Maybe let's wait for a second, maybe I can hear it. Is it understandable? Maybe let's wait for a second. Okay, I was hearing it and it seems like it's okay. Is the voice better now? Usually when I change camera, everything sounds good. Let me change camera for a second. Is it good now? Okay, nice. Yes, I couldn't participate in the contest. I just read the first few problems, but we're gonna solve them. I mean, we're gonna discuss the solutions of the problems. We're gonna need to read some of the solutions as well when we get to harder problems. We get there and we will discuss those solutions. But yeah, I try to ask someone else to do this one, but especially again this was not possible today, but thank you very much. Thank you for comparing me with Messi and Ronaldo. It's funny. Yeah, but we will get there. I hope that this can be helpful. Maybe that issue was with this plastic. Who was there yesterday? Yesterday my friend Yan was doing the stream. I haven't checked that yet, and I hope that yesterday you had a good contest discussion as well. What's IUI? Yeah, I'm wearing IUI t-shirt today. Maybe you can see it now. I was coach of Iran in IUI 2022. I'm wearing that t-shirt today. It's 34th IUI. But yeah, we can talk about IUI as well. But maybe it's now good time to start talking about the problems. Are you guys ready for it? What's that background corona sound? Really, you're hearing the voice in the background? It's weird. Maybe I should decrease sound a little bit. Okay, so let me know if there was any issue with the sound. Let me know about that. If while we're doing this stream there was any issue with the sound. So let's now start discussing the solutions of the problems. We're gonna go over them and see what happens. I haven't yet thought about D myself, but we're gonna see the solution together. No one could solve H today. That's interesting. And tourists did not participate, I guess. I checked this standing and I didn't see tourists. In ICBC, I asked him personally if he's gonna continue practicing or is he gonna save his rating. But he's gonna participate, and it's very interesting. I'm so interested to see how he will perform. I hope that he can break even more ratings and go on top of what he is right now. I mean, I hope he can reach greater levels as well. So, good. Let's now start talking about the problems. I think people have joined as well, and we can now start talking about the problems. Yes. The contest is rated. Why are you not taking topic stream? I'm gonna have a topic stream, but in the we had Codeforces rounds in consecutive days. That's why we had to delay the topic stream a little bit. Sure. We had to delay the topic stream, but for sure we have right now in our Telegram channel. I had a poll about what topic do you want me to discuss, to be discussed. We have three problem solving or permutation graph. You can choose in here in our Telegram channel. If you want, you can join there and talk that which one do you want to talk about, and we're gonna have our topic stream maybe on Wednesday, but we'll see. Okay, so now let's start talking about the problems. Let's first talk about problem A, sliding. It says that I read this problem. These problems seem easy. It says that there are n rows of m people. Let the position in the rth row and the cth column be denoted by R and C. Number each person starting from 1 in major row order. The person numbered R minus 1 times m plus c is initially at R and C. The person at R and C decides to leave to fill the gap. All the people will go leftward. I mean, from position J, they will go to position J minus 1. For example, this diagram shows that how they'll move. When you remove this red one, they will be like this. This blue one comes here, yellow one comes here, pink one comes here, and so on. And you have to say that, you have to calculate the sum of Manhattan distances of each person's movements. And if a person is at R0 and C0 and goes to R1 and C1, the Manhattan distance is R0 minus R1 plus C0 minus C1. So let's see how we can solve this problem first. So in this one, we have this like table. We have this table. We are removing one person from row number R and column number C. One person is removed. I want to see that how much everyone else are gonna move. Okay, I want to just find out the sum of how much the other people will move. Let's consider a row below these points. Let's consider a row here. For example, this row. I want to see that how people in this row will change their seats. Okay, I want to see that how the people in this row will change their seats and how much they will move. Well, first of all, I see that I know that I have many people in this row. I know that except the first person in this row, the rest of them will just go leftward. So except this person that I show with red color, the rest of them will just go leftward. So if it is n by m, if it is n by m, m minus 1 of them will just go leftward. So we have n minus 1 people that just move leftward. And this red one will come here. This red one will come here. So how much he moves, how much this red person moves? Can you guys say how much this red person moves when goes there? From the first, being the first person in this row, he goes to be the last person in the previous row. Exactly, m. Exactly, awesome. So it's gonna be m. Awesome. So this person, thank you very much, Fade. It's gonna be m. So if I sum up all these numbers, I have m minus 1 ones and 1m, which is gonna be 2m minus 1. So in all the next rows, 2m minus 1 movements will happen for all the people. In total, if I sum them up, it's going to be 2m minus 1 moves for them. We're going to have this 2m minus 1. And then this way we know all the people from the next rows. The only people that are left are the rest of the people in the same row. This person is at point R and C. I know that there are exactly n minus R rows after this row, and there are exactly m minus C columns after this column. So there are m minus C people here as well. We have m minus C people in the same row after this person at position R and C. And each one of them just go leftward by 1. Each one of them go leftward, therefore they will also add m minus C to the answer. So my final answer is gonna be, my final answer is gonna be n minus R rows I have after that row. Each row in total people will move by 2m minus 1. So I have n minus R by 2m minus 1. And then in the same row, there are m minus C people that move leftward by 1. So my final answer is gonna be this. So you see that by just conditioning and considering the people, I mean, for example, I consider all the people in the next rows separately. I saw that what happens to people in a row, in a row after the current row that we have. And also I considered all the people in the row number C, in the row number R. There are m minus C other people, all of them move only leftward. And this way I calculated the final answer. For example, let's see the example and see how it would work. For example, in the first one, we have our formula was n minus R. Our formula, as you see here, was n minus R times 2 minus m plus m minus C. You see that n minus R, n is 2, R is 1. So it's 1 times 2 times m minus 1, which is 5. 2 times 3 minus 1 is 5. So we have 1 times 5 plus m minus C. m minus C is 3 minus 2, which is 1. So we have 5 plus 1, which is 6. So you just seen n, m, R, and C, and you see out n minus R times 2m minus 1 plus m minus C. Between 2 and m, you should put a product as well. So this is gonna be your answer. Is it clear? Minus 1. Why do you think we need to also subtract 1 more from it? Because R and C are in one-base indexing, and n, when I subtract n from them, that's going to be the same. I mean, n minus R is really the number of rows after row number R, and m minus C is the number of columns after column numbers. So is it clear? Are you guys okay with that? If you're okay with that, please use this emoji or put a plus in the chat. For the last cell, I'm not sure what you're talking about. Call put count plus equal call minus y. Bottom right corner. Do you guys all believe that we need more minus an additional minus 1? I mean, yes, I think it's taken care of, because let's look at the others. I mean, it would work for all the cases. If you want, maybe I can implement it as well for you to make sure that everything is okay. If you want, we can also implement it. Who's Sayat? Do you mean Shayan? Oh, so you mean, I think you're talking in chats then. Yeah. Do you want me to implement it or move on to the next problem? Which one do you guys prefer? Whichever that you guys prefer, I can do that. Whichever most of you guys prefer. Yes, implementation, next. Don't say that, Ahmed. Next. Okay. Yeah, it's really 1 minute code. But I guess more people want to move on to the next problem. So I was okay with both. I was okay with both, but because more people want to move on to the next problem, maybe it's better if you move on to the next problem. If you want, at the end of the stream, I will implement it as well. So that's first, let's talk about the next problems because more people are waiting for it. And then at the end of the stream, if you guys want, I can implement it for you guys as well. Okay, sure. So I haven't explained B so far. So let's now move on to problem B. Problem B. It states that given a positive integer n, finds the smallest integer whose decimal representation has length n and consists of only 3's and 6's, such that it is divisible by both 33 and 66. Divisible by both 33 and 66. Well, first of all, the first thing that comes to mind, let's try to solve it step by step. What is the first thing that comes to mind when it says that the number must be divisible by both 33 and 66? Do you guys, I mean, what is the first thing that you guys think about when you see it? Exactly. Only 66 matters. 33 does not matter. I think it's, we have to solve all the problems. So yes, so only 66 matters, exactly. So when it says it must be divisible by 33 and 66, when it is divisible by 66, it's divisible by 33 as well. So there are several things that should matter when it has to be divisible by 66. Well, 66 is equal to 2 times 3 times 11, right? So our number must be divisible by 2. When it is divisible by 2, it means that it must be even. It must be divisible by 66. So it must be divisible by 2 and 3 and 11. That's the necessary and sufficient requirements for our number. It must be divisible by 2, it must be divisible by 3, and it must be divisible by 11. If we want it to be divisible by 66, it must be divisible by these three numbers. Then it is divisible by 66 and it is divisible by 33. So both of them will be okay. If the number is divisible by 2, 3, and 11. It must be divisible by 2, so it is even. So what does that mean when it is even? We can say that something must happen if it must be divisible by 2. It must be even. That's one thing that we can say. There's a fact that we can say. Exactly. The last number must be 6. Exactly. The last number must be 6. Yeah, yes. What you wrote as code is correct. So the last digit is 6. The next thing, it must be divisible by 2, divisible by 3. It must be divisible by 3. So when a number is divisible by 3, how can I make sure that it is divisible by 3? How can you find out if how can you make sure that the number is divisible by 3? Exactly, the sum of digits is important when we are considering that it is divisible by 3. So the sum of the digits must be divisible by 3. And it always is, because your digits are 3 and 6. Okay, your digits are 3 and 6. Each of your digits is 3 and 6. Each one of them are divisible by 3. So the sum of them is also divisible by 3. So the good news is that we do not need to worry about it. So we just say don't worry about it. It's okay. It is always divisible by 3. Let's change the color like the previous one. And it's always divisible by 3. Because all the digits are either 3 and 6. And when I put the full screen, the microphone gets messed up. Really? Do the rest of you confirm as well? Is it the same for all of you? So I can say that when the sum of digits is divisible by 3, the number is divisible by 3. And that's always the case because our digits are 3 and 6. So the sum is always going to be divisible by 3. So the only thing that remains is divisible by 11. So how can I make sure that it is also divisible by 11? I think maybe some of you have learned it in a school, and the rest of you, if you haven't learned about it in a school, you will learn it here right now. You will hear it now. How can I make sure a number will be divisible by 11? Does anyone know? Exactly. That's the important thing that I want all of you to understand well. If you want, maybe we can talk about it someday, about its proof. Its proof is not hard. It's similar to how for 3, the sum of digits must be divisible by 3. Exactly. As everyone said, then sum of the digits at odd place minus the sum of digits at even place must be divisible by 11. Exactly. So when we want the number to be divisible by 3, we just sum the digits. For example, sum of the digits. For example, when we have d of, for example, our number is like this. It has k digits. D of k minus 1, d of k minus 2, 2, d of 1, d of 0. For 3, we just sum up all these digits and we see if it is divisible by 3 or not for this k digits number. But when we have the same thing, when we want to have the same number and we want to see if this number is divisible by 11, what we do is this. We alternatively add and subtract numbers and see if that number is divisible by 11. And the proof is easy. If you want, I can talk about the proof as well. But because it's going to take time, maybe in one of the topic streams, I will talk about it. In one of the number theory topic streams, I talk about this proof. But for now, just keep in mind that when you want to see if a number is divisible by 11 or not, you have to consider this number. D0 minus D1 plus D2 minus D3 plus D4 minus D5. This must be divisible by 11. So alternatively, I add and subtract numbers. If I can make sure that this number is 0, I'm sure that this number will be divisible by 11. This must be divisible by 11. It can be 11 as well. It can be 22. It can be 33. But I say that if I make sure that it is 0, because 0 is divisible by 11, it's going to be good. So my plan is this. I want to make sure all the numbers in odd and even position have the same sum. I mean, if you sum up all the ones in an odd position and all the ones in an even position, I want them to be the same. I want these summations to be the same. If it is the same, then this value is going to be equal to 0, and therefore the number will be divisible by 11, because 0 is divisible by 11. So this is my plan. No, it's not just 0. I mean, it is not necessary for it to be just 0. It can be 0, 11, 22, 33. It must be just divisible by 11. But I'm saying that 0 is an option, so I try to achieve 0. If I achieve 0, I'm saying that if I achieve 0, I'm gonna have a number that is divisible by 11. But it's not necessary to achieve 0. Even if you achieve 11, or you achieve 22, or you achieve 33, those are all okay as well. Okay, those are all okay as well, but I'm saying that my plan is to make it 0. If I make it 0, I'm sure that it is divisible by 11. Okay, but it does not necessarily need to be 0. It can be any number divisible by 11. So I know that when I have n digits, I have these n digits. I know that my last digit is 6. My last digit is always 6. Now the point is that I want to make, as I said, odd positions and even positions have the same sum. Well, first of all, if n is even, it's easy for me. If n is even, I put 6 everywhere. So, for example, how many do I have now? 1, 2, 3, 4, 5, 6, 7, 8. For example, in here I have even. So, in the rest of the positions, I put 6 as well. Because there are even elements, I put 6 everywhere because it's the same number of 6 in odd positions. At even positions, the sum would be the same. So, if n is even, just put 6 everywhere. That's going to be a correct answer. I mean, it is possible. I have not yet talked about the smallest one. I have to make it the smallest as well. But I'm saying that this is going to be a correct answer. I mean, that would work. So the answer is not -1. But it's not the smallest number. But it would work if I do it like this. So the answer is not -1. So far I just showed that the answer is not -1. And a number exists, but it is not the minimum. Now, if I want to make it minimum, I can just say that the number of numbers in odd position and even position are the same. So I know that for one of even positions, I have 6. So I can just put another 6 behind it in the least significant even digits. And then the rest of them can be 3. So for the rest of them, I can put 3. This way, it would be the smallest possible as well. Because in the last position, I have a 6 in an even position. If we call it d of 0, if we call it position 0 and call it position n-1, in the last position, position 0, I have a 6. So in odd positions, somewhere I should have 6 as well. If all of them are 3, their sum would be less than the sum of even positions. So I need at least 1 6. When I want to make it the smallest, it's better if the least significant one be that 6, and the rest of them can be 3. Therefore, it is going to be the smallest number that is divisible by 11. And because the last digit is 6, it is also divisible by 2. And because all the digits are divisible by 3, the number is divisible by 3 as well. So that's going to be completely okay. So the even case is now solved. The even case is solved now. Do you guys agree with this so far? If you agree with it, please again put a plus or use this 100 emoji. So for the even case, I have solved the problem so far. Nice. 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 So now let's move on to odd, to n odd, the odd case of n. So now I'm assuming that n is odd. Well, if n is odd, I know that I have one more digit in even indices. For example, assume that n is 5. Let's see what I do when n is 5. I want to make the sum of odd positions and even positions the same, and also the last digit must be 6. So the last digit is 6, I'm sure about that, there's no doubt about it, I put a 6 here. Then in order to make the sum equal, first of all, I know that I have only 2 places that I can have I have only 2 odd positions. So what I can do is to first try to put 6s here such that their sum reaches, the sum becomes equal, and then in the rest of the numbers I will put 3. So for example, in this case it would work like this. I put 6 and then 6 and then 3 and 6. If you look at it, the sum of even positions is 6 plus is 6 plus 3 plus 3. And in odd position, it would be 6 plus 6. Both of them are 12. And they would be the same. If I had 7 digits, I add 2 additional 3s here as well. If I had 9 digits, I will again add 2 additional digits as well. And so on. So the point is that if the sum became equal, then when the sum became equal, then in the rest of the number digits, I will put 3. But I try to make the numbers for the last 2 odd digits digits at odd position, I have to make them 6 so that the sum at even position reaches the sum at odd positions. So I need to put 2 6s for odds and only 1 6 for evens. The 6 for evens is at the end, d of 0. Those 2 6s for odd positions is going to be at d of 1 and d of 3. This way I make sure that the sums are equal, and the number is the smallest one as well, because at least 2 of odd positions must be 6 so that the sum will be equal. And it's the best if they are the latest ones. But if we have less than 5 digits, so when n is odd, when I have at least 5 digits, it's good. The problem is solved again. The last 5 digits will be like this, and the rest of them I just put additional 3s. But when n is less than 5, for example, n is 1 or 3, the point is that I do not have the chance to put 2 6s at odd positions. I only have 1 odd position, but I know I need at least 2 6s at odd positions to make the sum equal. Because there is a 6 here, and the other one is at least 3. And even if I put another 6 here, still the sum in odd positions is less than the sum in even positions. So the sum does not have the chance to achieve. The sum at odd positions does not have the chance to achieve the sum at even positions. So if n is 3 or n is 1, there's no way that we can fix it. The answer is going to be equal to -1 in that way. So if n is 1 or 3, there's going to be no way the answer is going to be -1. Otherwise, if n is odd, the last 5 digits, the last digits for evens is 6, the last 2 digits for odds is going to be 6, the rest, they're all 3. And if n is even, the last 2 digits, the last one for the odd ones and the last one for the even ones are 6, the rest are going to be equal to 3. So this way, the answer can be calculated. So is it clear for you guys? If it is completely clear, please use this emoji or put a plus in the chats. Do you want me to implement the code? I think maybe you guys prefer if we move on to the next problem. So based on what I did, let me see, I lost your message. Let me zoom out. Fill the complete n with 3 except last should be 6, then move from the last -1. If not divisible, then change to 6, otherwise keep 6. Easy. Yeah, that would also work. We could put n 3s at the beginning and make the last one 6 and go leftward as long as it is not the sum is not equal. Makes them increase the ones at odd position. And guys, let me tell you something as well. Because being 0 is not necessary, is sufficient, I have to also show that not only this difference is not going to be 0, but also it's not going to be divisible by 11. It's not going to be divisible by 11 because the difference, you can see that when n is equal to 1, the difference is going to be 6. You have 1 6 at odd position and nothing in 1 6 at odd even position and nothing in odd positions. So in this case, it's obvious that it's not going to be divisible by 11 because the sum of the digits in even minus odd is going to be 6. When we have 3 digits, we know that the last one is 6, and then in here we have 2 numbers which are 3 and 6. So even they are the same, they do not differ. In that case, the difference is going to be 6, which is not divisible by 11, or one of them is 3 more than the other one. Either have 3 6 or 6 3. In both of the cases, you have 9 or 3 as the sum of the even digits and odd digits. So it's not going to be divisible by 11. So not only it cannot be 0, it cannot be 11 as well, or 22, or minus 11, or minus 22. That's not possible. So the point is that the difference between odd and even position, it cannot be divisible by 11 in any case this way. So that's what it's work. So I hope that is completely okay for you guys. Okay, so shall we move on to problem C then? Are you guys ready for problem C? Thank you, Aniket. Thank you very much. Okay, so if you guys are ready, let's move on to problem C. About problem C, I haven't thought about it yet, but we will now discuss the solution of it. Let's go over and read it once, then we see what people did. First we read it once, and then we see what people did, and then I will explain it from the beginning completely. So, problem C, Alia on permutation, it says that Alia has been given a hard problem. Unfortunately, she is too busy running for a student council. Please solve this problem for her. Given an integer n, construct a permutation p of integer 1 to n that maximizes the value of k. After the following process, perform n operations on the if operation. If I is odd, k is equal to k and pi. If I is even, k is equal to k over pi. And we want to maximize this number. We have to print the permutation. I will explain it completely at the end as well. After we saw what people did, I talk about the solution completely and talk about the statement and the solution completely. Let's see what people have done in this problem first. And you guys also can also tell me if you had a solution. You can also share it in the chats and we can discuss them as well. But for now, let's see what others have done it. Let me bring a code. Okay, so this is one solution that we see, and it is so small. It's a very small solution. It says that sin n, if n was odd, the answer is gonna be first. So it's like he's ignoring all the numbers from 4 to n minus 1, and he's considering n minus 1, 3, 1, 2 from the ends. So his last number is gonna be n, then n minus 1, then 3, and then 1, and then 2. And n is at least 5. That's why we have n equal to 6 here. What? Bad sound. We have a bad sound when I do not share the screen like this. It's a bad sound. Yeah, another person mentioned it as well. I'm not sure. Maybe. Let's see. Shoot this. Okay. First, let's see what these people have done. Still echoing. Yeah, I wasn't at home today. And I just came home just a couple of minutes before the contest. So first of all, let's talk about n is odd. Why is the answer if n is odd? Why it's better to put n at the end and then n minus 1 and then 3 and 1 and 2. And before that's all the numbers from 4 to n minus. So do you guys, any of you have any idea of why we can solve it like this? Let's see. We can maximum sum make equal to n, and even we make all bits set. When n is even, you guys make all the bits set. So what is the final answer that you're gonna get? You are gonna make all the bits set at the end. Let's get back over it. Yes. Okay, yes. Yes, that's right. When n is odd, the last one is gonna be and when n is even, the last one is gonna be or. Yes. So definitely when n is odd, the answer is gonna be at most n. The answer cannot be more than n because the answer is gonna be less than or equal to the last number that you've used. Because you have an and between the current answer, you have and the last number. So that's gonna be at most n, and it's like you can make n, and you say that if it is even, we can make everything set. Okay, so you want to make n when n is odd. So you put n here, and you want to make sure that before that you have all the bits. So you use n minus 1 before that. I see. Now I see what he's done. So you put n minus 1 before that to make sure, because it only does not have the last bit on, and then you use 3 and 1 to make sure that that last bit will be on as well. And then, okay. So, okay, I understood the odd case. I will explain it to you guys. So, but first let me tell you a summary. I want to first understand the even part as well and then explain the whole thing to you. So, odd case is very doable. It's a constructive problem. I mean, you're gonna build it. You just need to construct something in here. And maybe if I turn this off, you can hear me well then. I think you guys can now hear me well when I come back to the full screen. It is constructive when n is odd. You cannot make greater than n. You put n at the end, but you want to make sure that because we have and n, we want to make sure that before n your number is at least n as well. So you put n minus 1 at the end. N minus 1 just does not have the last digit on. It just does not have the last digit on. So before that, you put 3 and 1 so that the last digit will be on as well. So you make sure that when you get to n, all the digits are on and you're gonna have n. This way. So the odd case is okay now. I will explain it completely. But for now, let's move on to the other case as well. We want to say that we can make all the bits on if n is even. And how do we say this? K is the greatest. Well, wait a minute. Okay, this is the number that we want to. First, we print the number that we want to type. Okay. So we want to say that in this case, we can make all the bits on. Okay, yes, this is 2 to the power of. Okay, so he wants to show that all the bits can be on in this case. And in order to do that, he will put n at the end. And before that, 2 to the power of the biggest digit minus 1. Everything other than. Okay, I see. So it just does not have the last digit. Okay, and then k minus 2, because k minus 2 has. Okay, I now know the solution. I will explain it completely to you guys. Okay, so let's now talk about the solution. That was very similar. I mean, when you understand the odd case, again, first let me tell you a summary. When you understand the odd case, the even case are also simple. First, just consider 2 to the power of. I mean, this k is the 2 to the. I mean, we want to show that all the bits can be set. So n has the greatest bits. This number has all the bits other than the greatest bits. So similar to odd case, like what we had in here, we try to make sure that this number will be covered. So all the numbers except the greatest bits we have all of them, and when we have it or n, all the bits will be covered. This was just a short summary. I will first explain the problem and then I will explain it completely. So it says that, okay, let's first explain the problem again now that we know the solution completely. Problem C, alia and permutation. Alia has been given a hard problem, And it's this: given an integer n, construct a permutation p of integers 1 to n that maximizes the value of k, which is initially 0. After the following process, perform n operations on the ith operation. If I is odd, k is equal to k times k and p sub I. If I is even, k is equal to k or p sub I. You want to make sure that your number will be maximized, your k will be maximized at the end. So, how do we solve this problem? We just first we want to show that, let's assume that n is an odd number. First, assume that n is an odd number. Well, when n is odd, we know that the last operation is going to be AND. So we are going to do several things. We're going to have a number in here, and then at the end we will have AND a sub n. So our last operation is going to be an AND operation, not an OR operation. It's going to be AND operation. Now that the last operation is AND operation, we know that our answer is going to be less than or equal to a sub n. Because in general, x and y is always less than or equal to x and always less than or equal to y. X and y is less than or equal to both of the numbers x and y. So our number needs to be less than or equal to a sub n or p sub n. And we know that because it's a permutation, we know that this number is at most n as well. So our answer cannot be greater than n. Our answer is at most n. Because of this, our answer is going to be at most n. It cannot be greater than n. Okay? And now I want to show that n is also possible. I want to show that n is possible. How do I say that? I say that let's put n at the end. So it definitely we should put n at the end, because if anything else is at the end, this number is going to be less than n. We cannot have a sub n less than n, otherwise the answer is going to be less than n, because the answer is at most a sub n. So we put n at the end, and in here we want to make sure that our number will be at least n, I mean all the bits, all the on bits in n will be on in here. All the set bits of n must be set here. Must be set here. So how do I make sure that that happens? I say that let's put n minus 1 in here. N minus 1 has all the set bits of n. It is the same thing as n, except that the last digit, instead of 1, it has 0. Because n was odd. N minus 1 is even. When n is odd, it's some number that at the end of it there's a 1. It's some number that at the end of it is a 1. Then n minus 1 is the same numbers, the same representation. The only difference is that the last digit is 0 instead of 1. So it has all the set bits except the last one. Only that last one is 0 instead of 1. So when I have this OR n minus 1, I need to only worry about that last digit now, because everything other than the last digit is okay. All the other bits are here, and when I have them and n, I'm gonna have n. So now I need to make sure that in here, before that, that's 1 at the end will be okay as well. So the point is that in here, if I put 1 and 3 in here, if I put 1 and 3 in here, the point is that 3 and 1 is gonna, I mean in here, I'll make sure that my number is gonna have that 1. I mean when I have it or this 3, or all, I mean 1 and 3 can be in any order. Both of them works. If I have this in here, my last binary digit is gonna be 1, and then when I calculate and it's gonna remain 1 as well. And then when I have it or n minus 1 from here, n will come outside, and when n will come outside, n and n is gonna be equal to n. So my point is that You only care about the last 4 digits, and you just make sure that the last digit is n, the previous digit is n minus 1, the previous digit is 1, the previous digit is 3, or vice versa. This is 3, this is 1. Any other 2 odd numbers would work as well. And because your number is at least 5, this is okay. All these numbers are different numbers. So, about odd case, we knew that the answer is at most n, and now we achieved n. So we achieved the maximum. So this case is solved now. Odd case is now solved. So far, is it clear for you guys? If it is clear, please put a plus in the chat or use this emoji. This is for the odd case. Are you guys all okay with that? If you guys have a question, you might ask as well. If there are any doubts, you can ask. For the odd case, if the last number is even, is still the same. For the odd case, n is odd, so I put n at the end, and I know that n is odd. You know, the point is that I know n is odd. Okay, so the last number is gonna be odd. Yes, I'll repeat 3 and 1 again. Yes, sure. I will explain it again. I'm saying that. Let's put, I said that we have these numbers. At the end, we have and a sub n. So my number is going to be at most a sub n, because at the end I have and a sub n, something and a sub n. It's going to be less than or equal to a sub n, and it is going to be at most n. Therefore, my answer is at most n. My answer cannot be at most n. Now my goal is to show that I can achieve n. I want to achieve n. N is the best I can achieve, and I want to achieve that. So I want to achieve n, therefore a sub n must be equal to n. And do not forget that n is odd. We are considering the case where n is odd. Because when n is odd, the last operation is and. I'm only solving for n is odd. So a sub n must be n. Now I have something and n. Here I have all the numbers from 1 to n minus 1, and I have and n. Well, the point is that in here, if I can get n out of here, I'm gonna have n and n, which is gonna be equal to n, and that's gonna be awesome. So I want to get an n out of here. How do I do that? I say that let's put n minus 1 in the last position in here. I know that whatever n is, I know that the last digit of n is always 1, because n was an odd number. Now, I do this, I know that n minus 1 is the same number, just the last digit is 0 instead of 1. So these are the same. These are completely the same numbers, only the last one for n is 1, the last digit for n is 1, for n minus 1 it is 0. So now I only need to worry about that last digit, which is either 0, which is right now 0. I want to make it 1. In order to make it 1, I know that here there was an or, and here there was an and here there was an or. I put 1 and 3 in here, in any order I want, either first 1 then 3, or first 3 then 1. Both of them works. In here I first put 3 then 1, in here I put first 1 and then 3. Both of them work. The point is that your number here becomes odd, because we have it or 1, so the last digit becomes 1. And when I have it and 3, it is still odd, and the last digit is gonna be 1. It's gonna stay 1. So the point is that if you do this, the last number is gonna be the number that you're gonna have from here is gonna be an odd number. The last digit is 1. Or if I want to make it simpler for you to understand, you can put 3 here and 1 here, then you will for sure get 1 out of here. Because we have or 3, so the last digit is on, and then we have and 1. It's going to be 1, then we have 1 or n minus 1. This is going to be equal to n, and then we have n and n, which is going to be n. So we will get n at the end. Instead of 3 and 1, you could use any 2 other odd numbers as well. That would also work, because that would also ensure that the number that you have in here is gonna be odd. The last digit is gonna be 1. And therefore, when we have it or n minus 1, it is going to be equal to n, and then we have n and n. And do not forget that n was an odd number. This case was only for odd case. Is it now clear for you guys? If you are okay with that, please now use the emoji or put a plus in the chats. Do you have videos about bit operations? Not so far, not now. But if you guys want, I can make a video for that. So far, I do not have. Can you please everything for solution for every upcoming you're teaching? Thank you very much, Arif. I'm so happy that you say this. Thank you very much. I try to do it as much as possible, but also my friends are doing it as well, and they are also good as well. They are very good too. But I mean, maybe sometimes it's possible that it takes some time for you to get okay with other types of explanation as well. But everyone can. I mean, I would ensure that always, if anyone is doing the stream, it should have the greatest quality possible. I'm so happy that you like this stream right now. Thank you very much. And guys, if you like the video and if you want to support my work, you can subscribe to the channel or like the video. And also we have topic streams. In my topic streams, you are more than welcome. You're all more than welcome, and I would be happier as well if more people will join and I'm helping more people. That definitely makes my work more meaningful if more people are using it. So if you want, you can join the topic streams. To be alert of that, you can join my Telegram channel. There we will discuss about this topic streams. So it was for case where n is odd. If now you want, if you are now okay with that, now I can move on to the case where n is even. We'll talk about that at the end. That's a good question. I will talk about that at the end. I can tell you about my own experience. Yes, sure. So let's now assume that n is even. Well, when n is even, I want to show that and I know that n is at least 5. So it must be at least 6 then. And this is a general constraint. N is at least 5. When n is even, it must be at least 6 for even. This is general requirements, that is the general lower bound that is given to you, but for even it's going to be at least 6. So now we say that we want to show that if n, we see that how many binary digits n has. How can I see that? I can find the greatest k such that n is greater than or equal to 2 to the power of k. I can find the greatest k such that n is greater than or equal to 2 to the power of k. Then n is going to have k digits, k plus 1 digits. Or in order to make it more neat, it's better if I change it to k minus 1, assume that n is between 2 to the power of k minus 1 and 2 to the power of k. N is in such a range that n is greater than or equal to 2 to the power of k minus 1, and it is less than 2 to the power of k, then n is going to have k digits in binary representation. I want to show that you can set all the bits. Definitely you cannot make any other bits because they should come from somewhere. If none of the numbers have other bits in ands and ors, you cannot have them in your final result, in your final answer. Okay, so for the rest of the binary digits, you can never have them because they're not in any of your numbers. But these k digits that each one of them, some of your numbers had, you can just, I want to show that you can have all of them in your final answer. And how do I say that? How do I do that? Well, first of all, we say that let's put n at the end. Let's just put n at the end. Why I put n at the end? Because I'm sure that n has the last bits. N definitely has the greatest bits, the most significant bits, which I mean it's worth 2 to the power of k minus 1. Now, so from here I'm sure that the greatest bit will be okay. because I have or n. I mean, before n there is a or, because the case is even. Before n I'm gonna have a or. So at the end I know that I will have the greatest bits, because n has that. So about the greatest bits, I'm sure that I'm gonna have it. Now let's talk about the rest of the bits. How can we make sure that we have the rest of the bits as well? Well, let's consider that we have here 2 to the power of k minus 1 minus 1. The point is that this number does not have the greatest bits, but it has all the other bits. It does not have the greatest bits, but it has all the other bits. So it's good that it has all the other bits, but the only issue is that we have an AND before this one. We have an AND before this one. So we need to make sure that before that we have this as well. We have all these greatest bits as well. Because if before that we don't have these other bits, even when we have AND, they wouldn't be made as well. So what do? I mean, this number is odd. So I can really treat it like how I treated the odd case. I know that when my number is odd, I can make that specific number. How? Before it, I put another number 1 less than that. So I have 2 to the power of k minus 1 minus 2. And before that, I just add a 1 and a 3. Before that, I just put a 1 and a 3. Then it means that, again, that's exactly the same logic that I used for odd case. I mean, the same way I'm trying to make this number. This number is an odd number and I can make it. Before it, I put 1 less than that. I put a number 1 less than that. That's exactly the same number, only the last digit is going to be 0. So I need to make sure that this last digit will be okay as well. And because of that, I put two odd numbers before that. 1 and 3. I know that after here, I get a 1. Then when I have 1 or 2 to the power of k minus 2, the result of here is going to be 2 to the power of k minus 1 minus 1. When I have it and 2 to the power of k minus 1 minus 1, I still have the same thing. And when I have it and n, I know that n has the greatest bits. And 2 to the power of k minus 1 minus 1 has all the other bits. So at the end, I will have all the bits set. So I will have the maximum that I can have. So I put n, then 2 to the power of k minus 1 minus 1, then 2 to the power of k minus 1 minus 2, then 1 and 3. And this way I have all the bits on. I think there's only one specific case for when n is equal to 6, because when n is equal to 6, this 2 to the power of k minus 1 minus 1 is gonna be 3, and I'm gonna have 2 3's. So I will solve the case for 6 separately. But this case is gonna be for greater than 6. I mean, if n is greater than 6, you know that all these numbers are different. N and 2 to the power of k minus 1 minus 1 and 2 to the power of k minus 1 minus 2 and 1 and 3 are all different numbers. So it's going to be okay. Only if n is 6, this is going to be 3 and this is going to be the same as this 3. And it's going to be about problematic. So we solve the case where n is equal to 6 separately. For 6, you get the answer. For n greater than 6, it can be solved this way. And then for odd cases, it would be solved easily as well. I'll show you the answer for n equal to 6 as well. I'll show you that when n is equal to 6, how you can do it as well. And this way, all of the cases will be resolved. Is it clear for you guys? Thank you very much. Yes, we treat 6 separately, yes. And yes, exactly, 6 is given in the test cases. Yes. So for 6, we just print this, what we have. Could you explain the... Yes, for n less than it, you can just copy paste the example. Explain the 2 to the power of... Yes. Yes, sure. I will do that. Sure. So, assume that, for example, your n is 10. Assume that your n is equal to 10. So, when n is equal to 10, I first want to see that how many digits n has. In how many binary digits. Okay, in base 2, how many digits? So what is 10 in base 2? you definitely need to know what is base 2 in order to solve this problem. So you guys know it. So what is n 10 in base 2? Would you say it was a good problem? I personally don't like this type of problems that much because it's not that beautiful and those great ideas. I personally don't like this type that much, but this is a constructive and this is needed as well. You need to solve these kind of problems to train your mind as well. I mean, so that's basically what you have to do. We need these kind of problems as well. So there's nothing that we can do. You should never skip such problems. So okay, exactly. It's gonna be 1 0 1 0. So it's gonna have 4 digits. How can you find out how many digits n has? It's just enough to see that what is the greatest power of 2 that is less than or equal to n. If n is between 2 to the power of k minus 1 and 2 to the power of k, for each n you can say that what is the greatest power of 2 before it? What is the greatest power of 2 before it? And then if n is greater or equal to 2 to the power of k minus 1 and less than 2 to the power of k, it means that it has k digits. For example, here 10 is greater than 2 to the power of 4 minus 1 and less than 2 to the power of 4. Greater or equal to. So it has 4 digits. Okay, so it has 4 digits. So first I see that how many digits I have, and I say that I want them all. I know that this is the most that I can get at the end. At the end, at most, I can have all these bits on. That's the most that I can get. So I want all of them. Give me all of them. That's my approach. I want all. And how do I make all of them? How do I achieve all? I say that first at the end, let's put 10. Let's put my value of n. I know that n has the greatest bit. For example, here the most significant bit is this one. I'm sure that 10 has this one. Okay, I'm sure that when I put n at the end, I have the greatest bits. And because there's an or before it, I'm pretty sure that because there's an or before it, this bit will be covered. I mean, this bit would be correct, and there wouldn't be any issues. Before that, I put 2 to the power of k minus 1, which is 7, because I know that 7 has all the other bits, all the less significant bits. This one has this 10 at the end, had the greatest bits, and the rest of it can be anything. I do not care about the rest of it. I think you could also put 8, 2 to the power of k minus 1 there. That would also work. There's no difference between these two. And before it, you have this 7. This has all the other digits, but there's an and before it. So in here, I need to have all the other digits as well. Otherwise, when I have them and 7, if I do not have a digit after and with 7, I won't have them as well. So in here, in order to make sure, I know that 7 is an odd number. And previously, I talked about when I have an odd number, how to create that odd number itself. I said that just before it puts a number one less than that, we know that 6 has everything that 7 has except the last digit. The last digit in 6 is going to be 0, in 7 it's going to be 1. So 6 is going to have everything that 7 has. Only the last digit is not the same. And before that, let's put 1 and 3 in any order. Either first 1, then 3, or first 3, then 1. Then I'm sure that from here, I'm going to have the last digit because I have or this. In order to make it simpler to explain, I can just put 3 here and 1 in here. Both works, but this way it's easier to explain. I can put 3 here and 1 here. Then I know that the number that comes out of here is odd. When I have it and 1, from here, I will get 1. And then when I have 1 or 6, from here, I will get 7. So I will get this 0, 1, 1, 1. And I have it and itself, so I have 0, 1, 1, 1, 1, 1, 0, 1, 1, 1. Therefore, I have all the digits except the greatest digits. And then when I have or the number n, I'm going to have the greatest bit as well. Therefore, I'm going to have all the digits on. Therefore, I can get all of them. This is for the case that n is greater than 6. If n is equal to 6, in the samples, you know that what is the answer. And you can just copy and paste it. Why n must be greater than 6? Because otherwise, if n is 6, this number is going to be 3, and you're going to have 2 3s, which is going to be problematic. But when n is at least 8, 2 to the power of k minus 1 is going to be at least 8 because it's greater than or equal to 8. Therefore, you will never touch 3 and everything would be okay that way. Is it clear now, guys? I like this problem because you have to figure out how to set alphabet without setting the bits. Yes, that was nice. Yes, all the constructive problems have some ideas definitely, and that's gonna be helpful. And yeah, let me also show you the code as well. If you want, I will show you Python code as well. Yeah, great. It's great if you guys enjoyed it. So each one of you say that if you enjoyed it or you didn't. So what do the rest of you guys think? It was enjoyable, yeah. I mean, just trying to work with them. That has some ideas, definitely. About the code, as you see in here, this is the code. If n is odd, similar to what we solved. If n is odd, just put, I mean, we use this code to explain everything. So if n is odd, I put n at the end, before that n minus 1, and then 3, 1, and 2. This 3 and 1 makes everything good. And then the rest of the numbers will be just printed before this. They are not important. I mean, I do not care what happens before those numbers. Only the last 4 numbers matter for me. The rest of them have no effect. They cannot help. So I can put them in any order I want. For 6, that is going to be this special case. I can just copy and paste what I had in here. For other even numbers greater than 6, I can just find here k in here is that greatest power less than or equal to n. I can have that greatest power minus 1, and I can have k minus 1 in here, k minus 2 here, and then again 3 and 1 and 2. So this is that greatest possible number that I can have. I mean the greatest power of 2 that I can have is gonna be k. This is gonna be 2 here it says 2 times k minus 1 because that's if I have all the bits set. And here I put k minus 1. It has all the bits except the greatest bits. And k minus 2 and 3, 1, 2, this way, all the bits except the most significant bit will be covered. And then when I put n at the end, that greatest bit will be covered as well, and everything will be okay. So this way the problem can be solved easily. I said it several times. I couldn't participate in the contest. I had work student, I was in the university. So I couldn't participate in the contest. Well, you can't also take n minus 2 minus 1. N minus 2 minus 1 does not necessarily have all the bits except the most significant one. 2 to the power of k minus 1 has all the bits except the greatest one, but n minus 2 minus 1 is not like that necessarily. It does not have all the bits except the most significant one. Can you dry run for n equal to 8? Yes. I can dry run for n equal to 8. For n equal to 8, that 2 to the power of k minus 1 is going to be 4. 2 to the power of 4 minus 1 is 8 itself. So in here, I will put 8 itself at the end. Then before that, I have 2 to the power of k minus 1. Minus 1, which is going to be 7. Then before that, I'm going to have 6. And then before that, I'm going to have 1. And here 3. Now I know that from here, an odd number comes out. Therefore, from here, 1 comes out. Therefore, from here, 7 comes out. Therefore, from here, again, 7 comes out. And therefore, from here, I have 7. Or 8 is going to be 15. All the bits are going to be set. 7 had the last three ones, and 8 has the most significant. Is it clear for everyone? No, I'm not living in Iran. I live in the US. Yeah, I think you need to speak English a lot in order to get familiar with it and be okay with it. I think over time it gets better. If you train, you can train just like it. That's about training English mostly. You can just train English to get better in that. Yeah, we can talk about it at the end of this stream. And thank you guys very much for the emojis. That means a lot. All of the emojis, even this laughing ones. Thank you. How to get better at implementation. I can talk more about it, but about briefly talking about it, just you need to solve a lot of problems. That's the main important thing. You're gonna need to solve a lot of problems to get better at implementation. That's how you improve. If anyone tells you anything else, for example, I have this hack that helps you to get better, that's lying. There's no hacks. You need to do it in the hard way. And if you want, emoji freaks are yeah. No, that's funny. That's interesting. If you want, you can also watch the interviews that I had with other competitive programming competitive programming legends. You can watch them in this stream. I talked with them, and they have also talked about how we can get better, and you can watch them. You can watch them in this topic, in this playlist. You see, for example, I talked with Omnik, with Reina, who has IOI gold medal, with Kavi, the first Iranian LGM, with Ors and other mods that you must know. They are very famous in Codeforces. And I talked about it with them. All the things that they guys said as well was that you need to do it in the hard way. You can just watch that and see what they said in more detail, but the summary of it is that we need to do it in the hard way. There's also a video from Omnik that says everyone can be Grandmaster. That was very inspirational as well. I mean, if you want, you can watch that too. How far can you get with Python? Python, you cannot solve. I mean, you can always solve easy problems, but some of the problems you cannot solve them because Python is slow. And sometimes in problems, your constraints are tight and you cannot solve it using Python. Therefore, so sometimes you cannot solve it using Python. If you are solving, for example, problems D, E, then you need to switch to C++ instead of Python. YouTube does not pay me much. I mean, it's joking, like maybe $30 or something, and I have not even received it so far. I have not received any money from it. It just adds some value, but it's almost zero. I don't know if someday it's gonna pay me for something or not. But so far, there wasn't anything. Yes. If you solve very quickly, you can reach a specialist. If you solve the first two problems. Yeah, usually that's. What time is it right now? In Maryland, it's 3 p.m. 2:58 p.m. Yeah. I think right now, even before that, he knew how to code. And it's just 1 year after he made his Codeforces account, not 1 year after he started. So, yeah, minus 232 company contribution. That's okay. There are some people also that try to downvote my blogs. If you have seen my blogs in Codeforces, you have seen that initially some people try to make it negative, but over time people come and it gets back to positive when people start voting. But I don't know. I think some people just like downvoting, and when initially I put a blog, I think they have a lot of fake accounts and they log into all those fake accounts and try to downvote me. That's why at the beginning I sometimes see it downvotes, but over time it gets positive again when more normal people are seeing the blog. That's happened. I mean, maybe you should. I mean, about some people, there's nothing you can do about them, so you should not care about those things sometimes. But if your comments are really bad, or I mean, your comments or your blogs are really something that people don't like, maybe you should rethink about posting them. So just take a look at them. If there's any issue, if people didn't like your comments or blogs for a reason, try to see what is the issue and maybe you have to fix it. Please say hello, Kazakhstan. Hello, Kazakhstan. I was in Kazakhstan very recently for ICPC, and it was a very beautiful city. He's from India, so technology, but any chance? I don't know, maybe I've met him. Maybe I've met. Okay, guys. Do you want to move on to problem D as well, or do you prefer if we continue talking? I'm okay with both anyway, but I just want to make sure that which one do you guys prefer. Okay, sure. Which country are you? I'm answering this question in every topic stream and every solution discussion. So can anyone answer this? Which country I'm from? First of all, you can tell me that how do I look like? I mean, from which country I look like to be from, and then I can answer you. yes. Okay, let's now move on to problem D as well. I haven't thought about this problem so far as well, but we're gonna solve it like problem C. We're gonna see the solution like problem C. So it says that you are given an array B of length m. You can perform the following operation in a number of times. Choose two indices, I and j, such that bi is even. Divide bi by 2 and multiply bj by 2. Your task is to maximize the sum of the area after performing any number of such operations. Since it can be large, output this modulo 10 to the power of 9 plus 7. And since the problem is too easy, you are given an array A of length n. You need to solve it for each prefix of A. So for each prefix of A, you want to maximize the sum. What you can do is to pick an even number, divide it by 2, and pick another number to the right of it and multiply it by 2. Okay, so I will explain the statement in more detail. I mean, we will spend more time on that. But for now, let's first see that what is the solution. Let's figure out the solution first, and then we will talk about it in detail. Problem E was awful by Yan. Hi Yan. Did you participate in the contest, Yan? I didn't see you in the contest. But I haven't even read problem E yet. And yes, guys, I'm from Iran. I'm originally from Iran. Right now, I'm in the States. I'm in Maryland. I'm studying my PhD right now. So let's talk about this solution. Let's look at the solution. I'm waiting for it to load. Okay, so in this one, this is a very short code from this person. He says that when we have an x, first he tries to find out how many 2's this x has, and while t and y was greater than 31, or a sub t was less than or equal to x, y shifted by y. So y shows that how many 2's this number has. S plus equal to m minus a sub t times qp of qp is power. So it's qp is power m minus a sub t times 2 to the power of b sub t. What is t? Okay, it's 2-pointer, or if while a sub t was less than or equal to IC, So it's using a greedy algorithm. He compares a sub t with the number that we can have at max right now. As long as that number can be less than or equal to this, a sub t was less than or equal to x shifted by y, s plus equal to n minus a sub t. Okay. Plus a sub t modulo m. Okay. So he goes leftward as long as he can make this number greater than that one. He will divide that number. I mean, he will give the 2's from that number to this new number that has arrived. As long as he can. Oh, okay. It's like he has a stack of numbers. So he has a stack of numbers. He tries to keep the ones that are gonna own the 2's that you have. And each time and the 2's should be somewhere that they can make the greatest possible number. Okay, I think I know how it's being solved. Okay, I think I got it. So let me first talk about it again, tell the statement completely, and then we will move on to the solution. So problem D, yet another real number problem. It says that you are given an array B of length m. You can perform the following operation any number of times, possibly 0. Choose two distinct indices I and j where both of them I is less than j and both of them are from 1 to m, and bi is even. Divide b sub I by 2 and multiply b sub j by 2. Your task is to maximize the sum of the array after performing any number of operations. Since it could be large, output this sum modulo 10 to the 9th plus 7. And since this problem is too easy, as it says, you are given an array A of length n and need to solve the problem for each prefix of A. In other words, denoting the sum, the maximum sum of B after performing any number of operations at f of B, you need to output f of A1, f of A1, and A2 to f of A1 to An, modulo 10 to the power of 9 plus 7. So for each prefix, you need to find out that what is this answer at maximum. Well, the point is that at the end, the first observation that we can say, the first fact, the first observation is that it's always the best if each of your tools, you have several tools, right? You have several tools. Each number is a odd number times several tools. For example, if you have a number like, for example, 60, it's equal to 2 times 2 times 15. So you have 2 2's and then a 15. So each number has some 2's and an odd number. So each number, like x, is equal to 2 to the power of some t times some y, for example. So let's consider that each number, how many 2's this number has, and what is that odd number that remains at the end for this number. And because the reason that these 2's are important, because you are just moving 2's. What you do is that for example, you have two numbers. For example, you have an A here and a B here. You know that this one has 2 to the power of, for example, S. This one has 2 to the power of T. what you do is that you will give one of the 2's from here to here. So this one has gonna have 2 out to the power of s minus 1 is gonna have s minus 1 2's, and instead this one is gonna have plus 1 t plus 1 2's. So you are moving these 2's. That's what 2's are important. You have some base which is an odd number, and you are moving these 2's, and 2's can only move forward. They cannot go backwards. You can pick a 2 and give it to a number to the right. Now the point is that each 2, the main observation that we have is that each 2 tries to be in a number, that is maximal, possible, or that is maximal. So we try, each 2 tries to go somewhere that is such that number will be maximum. I mean, even if after going there, that number will be maximum. For example, assume that here you have a 4, you have a 3. This number is greater than this number. But if you move this 2 to here, this number to the right is going to be greater than this number to the left. It's always better for a 2 to go to a number that is maximal, because this way it has doubled a number that is greater than this previous number. So in total, it's going to be better. Even if we have, for example, we have 8 and 3, by moving 1 to, still this number is greater. I mean, as soon as it is 16 and 3. But after moving 1 to, still this number is greater. But if you move all the 2's to that 3, the right number will be greater. So the point is that each 2 wants to be in a number that number is maximum possible. Each 2, as long as they can, they will go to right if they can make a greater number. That's what gives us the intuition of using the greedy algorithm. We can use the greedy algorithm, and that works like this. We try to move a number rightwards such that it maximizes the numbers. Each 2 wants to go to a number that maximizes. It can maximize, that number will be maximum. So for example, if a 2 can make a, for example, 20, it will never stay in a number that is, for example, 16, for example. So the point is that you can make a stack. Each time your 2's are going to be in some places. Okay, so for example, assume that you have added these numbers so far. Now you're adding another number. So your 2's, assume that are here. Your 2's have moved to these places. These red ones are the ones that have the 2's. The others have gave their 2 to these red numbers. It definitely means that this one is greater than this one, greater than this one, and greater than this one. Why? Because this number couldn't become greater than what it is right now. There was no way to make, I mean, if this number was greater, those 2's also wanted to come here. But because they haven't came there, it means that it is less than that. This number is less than that. Okay, so basically we are trying to move these 2's to the right. If we only do not do that, if this happens, that by moving that there, this number wouldn't be greater than what we had to the left. So do not forget that the main thing in this problem is that your 2's will go somewhere that number will be maximized. Okay, is it clear so far? There's some siren out there. I don't know if you hear that or not. Okay. So, nice. So now when another number will be added, the point is that now the 2's that you had already, now they can also come here. Now they can also come to this new place. And each time I can see that what is the maximum possible number that I have here. It's gonna be some number that I have. It has some 2's right now, and it has some base which is an odd number. I see that what is the product, and I see what is this number, and I compare it always with the last number in my stack. I see that if this number can be greater than that, if what I have currently here was greater than the base here, if everything that I have currently in here, even considering the 2's, was greater than the base here without the 2's, it means that if 2's come to this part, this number, they're gonna make a greater number. Therefore, I will move them here, and I will make this new number greater. So if this new number, currently was greater than the base of the previous number, I will move these 2's here, and this one will be removed from this stack, and I will continue doing this. As long as that happens, I will keep removing these elements from the end of the stack. At the end, I see that how many 2's will be added, and at the end, I will add this new one to the end of the stack as well. And in the meantime, I will update my sum, etc. Guys, the charge of my laptop is not very good, and I think the quality has been decreased. So let me bring the charger for a second. I will come back in a moment. Sorry for that. Okay, sorry, I brought the charger back. So that was the main thing in this problem. The point was that when I add a new number, I just see that when this number will be added, I just see that if I can make a greater number here or not. I mean, I compare the maximum number that I can have here compared to the base that I had there. It's like I'm trying to find out the 2's that I had in here. Is it better if they stay here with this base, or if they come to this number with all the 2's and etc. that they have? And if it was better to go there, I will move them there, and I will remove this one from the stack. And this way I will update everything, and everything will be calculated. So does it make sense? Is the solution clear for this problem now? If it is clear, please use this emoji or put a plus. How do we check if it is better or not? Well, we put that was a very funny comment. So we put this last number, we compare it with the number of 2's that it has. We have the number with all the 2's that it has, and in here the base that we have. So the point is that we have some 2's in here. Let me bring the tablet again. We have some 2's in here. We multiply it by this odd number right now. But now we are comparing that. Is it better to compare it with this odd number that we had in here? It's better to multiply it here, or multiply it by the number that I have in here. We see that which one is better. And whatever that was better, I will, if that one was better, I will move these 2's there, and this one will be removed from the ones that have 2's. It gives all the 2's to that last number. So I will just compare these two numbers. Even if you take a look at this, yeah, sure. I can try run a test. Maybe, for example, we can just consider the second test case. If you take a look at the second test case, it's gonna be 1, 2, 1, 6, 9, 4, 7, 4, 4, 10, 3, 2, and 3. So this is the numbers that I have right now. Okay. So what I do is that first I add this one. Its base is 1 and it has no 2's, so it remains as 1. So this is nothing. It adds is 1. So then this 6 comes. It has 1, 2. It has only 1, 2, and the base is 3. I write the number of 2's that it has in here and the base here. The base is 3. For this one, the base was 1 and it has 0 2's. So it remains in here, the sum is 7 right now. Then this 9 comes. When this 9 comes, its base is 9 and it has 0 2's. Now the point is that in here, the 2 that I have in here is better if it comes here. I compare this 3 and this 9. I see that this 9 is greater than this 3. So it's better that if that 2 will be multiplied by that 9, not by that 3 that I had previously. So this 1 moves here, I remove it and add it here. So here I'm gonna have 18, and in here I'm gonna have 3, and in here I'm gonna have 1. So this 1 will be moved because 9 is greater than 3. Then this 4 comes. When this 4 comes, it has 2 2's and then the base is 1. I compare it with 9, I see that if the 2 stays there is better because it's there, it's multiplied by 9, but here it's multiplied by 4. So that doesn't move. Then this 7 comes, the base is 7, and it has 0 1's, 0 2's. Now I see that I start from the end. I compare it with this 4. Right now the ones that have 2 are these 2. These 2 numbers have 2's. The rest do not have 2. I compare it with this 4 first. I see that these 2 2's are better if they will be multiplied by this 7 rather than being here multiplied by 1. So I compare this 1 with the number that I currently have in here. In here I have 7, in here I have 1. 2 2's are being multiplied by 1, but instead they could be multiplied by 7. It was better if they were multiplied by 7. So first of all, I remove this. I make it 0 and add these 2's to that 7. And I will update the sum accordingly. And this one will be removed. Then I compare it with this 9. Here the base is 9, but the number that I have in here is currently 28. So I have a 2 that can be either multiplied by 9 or could be multiplied by 28. So it's better if I move this one to here as well. So I will move an additional 2 from there to here. So this 9 from here will be removed, and I will have another 2 in here. So right now I have 3 2's here. Then 4 comes. It's better if we keep the 2's as they are. Another 4 comes. I see that for the previous 4, I had 2 2's that were multiplied by 1, but now they can be multiplied by 4. So again, I will move this 2 2's to here. This becomes 0, this becomes 4, and this one will get removed from the ones that have 2. And I will continue this process. I will move forward and continue this process, and this way I can have the best answer that I can have. So this is how it will work. I have this stack. I know that all the numbers are in decreasing order in a stack because I know that 2's will go to the maximum number they can. So if it was 2 of them were in increasing order, all the 2's that were here would move to this one instead. So each time I see that when a new number will be arrived, I see that I compare it with the last number in the stack. I see that can I take the 2's from that one? That is the easiest one. That is the smallest one, and that's the easiest one to take 2 from. If I can, I will move 2's here, and I will remove that one from the stack. Right? Is it clear now? I got the solution, but I want to know what would your thought process be once you see this question at this rate. I think my thought process was also that you need to do a greedy approach. I mean, the first observation that really helps you to solve this problem is that 2's are better to be at the end. That's very important. Since it is modular, we cannot actually multiply and compare, right? Yes. That's why I will show you the code and we will see how it can be updated. Yes, no, not the base values. For the left one, we consider the base values, but for the right one, we also consider the 2's as well, because 2's are right now there. In here, we have some 2's and some base. These 2's are being multiplied by this base. I want to see that if it is better to be multiplied by this base or by this number. So I compare the whole number with this base. And how do I do that? I see that, you see that, for example, in this code, if y was greater than 31, definitely this number is greater than that one, the base of that one, because the base of that one is less than 2 to the power 31. Otherwise, I just compare it completely. I see that what is x times y to the 2 to the power of y. I compare it with a sub t, and if I can, I will move the numbers here. And this is how I can calculate it. Is it clear now? Yeah, I see. I mean, the approach is gonna be exactly like this. I mean, let me send you the link to this code. I read this code and I explained to you based on this code. And the point is that if you go this way, I mean, this is the best way basically to implement it. And you see that it's very short as well. You get the numbers, you see that how many tools they have, and as you go forward, you have a stack. This is a stack. A and B are stacks. A means what is the base case, B means what is the number of tools that we have. Each time we are comparing the numbers, and if the first number, I mean, we compare the base number of this one at the end of this stack with the number that I can have to the right side. And then each time, if that was possible, I will update the sum. How do I will update the sum? First, I will remove these tools from this number. I previously had A sub t times 2 to the power of B sub t. I will subtract that from my answer, my sum, and then I add A sub t alone, because now A sub t is alone. This way I update, and I have this y. This y is going to be the number of tools that I'm going to have at the end for this number. At the end, I'm going to add x times 2 to the power of y to my final answer. And this way the answer can be calculated. It's the best way to implement it. Did I send you the link? I guess I forgot to send you the link. Can we use a mean heap? You can also use a mean heap because they're in sorted order, but stack is faster. You're basically shifting the recorded till now tools. Yes, exactly. Nice. Yeah. Can you explain what exactly is the stack storing? This stack is storing all the numbers that own the tools. We know that the tools will go to several cells. They will not stay in their initial place, because sometimes they see greater numbers and they want to go there. The stack contains all those numbers that owns the tools, that got the tools. So all the numbers that have the tools are going to be in stack. The rest of the numbers that they lost their tools, they're going to be outside. They will be removed. So everything that has lost their tools, they will be removed, because they will not change anymore. They are not important anymore. The rating of this problem, I think like 15, 16 or 1700, something like that. 1700 maybe. Or maybe more. We can take a look at the standing and see that how many people and how they accepted the problem. From what I see, and the rating changes came now so fast. From the standing, I see that problem D is solved by some of the expert answers. So it's around experts. I see that most of candidate masters have solved the problem, and below expert did not solve the problem, but expert was maybe the threshold. So around the expert. So maybe 16, 1700 made sense. Yeah. But should I get a TLE if I use mean heap? I don't think so. I think maybe even with a mean heap you can get accepted, I think. Yes, exactly. I boiled the problem down to shifting tools, and then after that, yeah. Exactly. Nice. Can you show the stack using the test case? Yeah, the stack, I showed it. The stack is this red cells that I have. For example, you see that in here this 7 and this 4 have a red circle around them. That's our stack. Because for example, here the 7 and the 4 are the ones that have the 2s. For example, next one, this 10 comes. When this 10 comes, it will get all the 2s from here, because if I compare it, 10 itself have a base of 5 and 1, 2. Here, I see that here I have 10, but my base here is 1. So I move all these 4 2s from here to here. I have 5 2s here. Then I know that I have 320 in here. I compare it with this 7. So this 4 will get removed from my stack, And then when I compare it here, I see that it's even better to even move these ones as well. So this one will be removed as well, and I have 8 twos here, and this 7 will get removed from my stack as well, and then I will have this 10 here in my stack. This is how my stack, I keep my stack. Does it make sense now? Instead of stack, we can we keep those in a vector and then binary search in that vector. You can use a vector instead of a stack, but the point is that you don't need a binary search, because each time you just work with the last element of that vector or that stack. Yeah, you're welcome. I'm so happy that you liked it. Yeah, I hope that it's helping you guys. Any other questions about it? That's nice. And guys, do not forget to participate in the votes for the next topic stream. We had 2 main options. Either we can talk about solving 3 problems or about permutation graph. I basically think that 3 problems are more common, but you can vote. You can vote that which one you want. Both of them are necessary at the end. I mean, you have to know both of them. Maybe 3 problems are more common in Codeforces and everywhere, and this is maybe because of that, that's going to be more helpful at the beginning. But permutation graph is also something that needs to be covered, and if you guys want, I can first, because in the last CF contest that I streamed, there was a problem using permutation graph, and we can talk more about permutation graph and how it can be helpful. So that's also something that can be very helpful. So you guys can vote about that in Telegram, and we're gonna have this topic stream either on Tuesday or Wednesday, and we're gonna talk about all these topics. So far we had several topic streams. Let me also send the links to them as well. If you guys want, you can watch these topic streams. Let me also show it to you guys. We have all the topic streams in here: dynamic programming, number theory, graph algorithms, and it has more than one sessions. We discuss many different things: problem solving on dynamic programming and graph algorithms. We had all these things, and we are gonna discuss the next things as well. I have both of them topics for permutation graph or trees, both of them prepared. Based on whatever you guys want, I can cover that one for you for the next one. Let me also send you the link in here. Please do more topic streams. Yeah, sure. I try to do more topic streams, and thank you very much. I'm so happy that you like the explanations. Yes, right now there are so many contests, and we have, because of that, so many streams. Will you explain E? I haven't read or solved E, but if you guys want, we will now talk about E. I haven't thought about it, but if you guys want to talk about it, we'll talk about it now. If you don't need it, we can skip that, but if you want, we'll talk about E as well. What is your future ultimate goal, Cheyenne? Basically I like startups, and that's the most important passion of mine. I'm learning several other things, and I'm doing some works, and that's the main thing that I'm following up right now. But we can talk about it at the end. Maybe for now, we can talk about the problems. Do you guys want to talk about E as well? Does anyone want to talk about E as well? Curious if you got stuck as a problem, how long do you work on it before you go to the solution? Some suggest to stay long, like Colin Gallen. Colin is my friend and my ICBC teammates. The moment they are stuck. I think Colin also believes that when you are stuck, you can take a look at the solution. I also believe that when you are stuck, you can take a look at the solution. You have to stay long, but as long as you can arrive, some ideas can arrive to your mind. But when you see that you are stuck and you have nothing else to do, it's good to see the solution. I mean, at least read, for example, one line. Maybe after reading one line of tutorial, you have some idea about what you can do. and you don't need to read the rest of them. Then you read one line and then continue thinking. Again, think about the problem afterwards. So you can just take a look at that and continue thinking afterwards after you read some part of the editorial. That's very helpful. I mean, don't spoil it completely. If even with reading some part of it, you can continue thinking. But if you're really doing no progress, I mean, you have very, very little progress by spending time, you can just, take hints. That's okay. I mean, you need to train efficiently. And if you just stay on a problem for example, 20 hours, especially if your current rating is not very high. For example, maybe for legendary grandmasters, it's okay to spend 20 hours on a problem. But if your rating is below some threshold, you need so many problems to be solved. You need to see so many ideas. So it's not good to spend a lot of time, and especially when you're stuck on those problems. So when you are stuck, it's okay. I mean, you feel it when you have ideas and when you don't have ideas. I don't know. Yeah, symmetric groups. Yeah. There's also one very advanced topic, Burnside lemma. I don't know, someday maybe we can also talk about Burnside lemma as well. Yeah, we can talk about these things, but we have to go over everything step by step. So first we need to build first we're gonna talk about the topics step by step. But the problems we solved are even gather hard problems that will be solved with little knowledge of topics. So it's only ideas, little knowledge of topic, and these problems can be solved. But yeah, we will talk about everything, but yeah, step by step in different topics. Sure, I'll try to cover everything that you guys need to be covered. Stream on tries, yeah. Sure, we can do that. Skip E, yes E. I can't do E yet. Thanks for the stream. See you on the next one. Sure thing. So, let me see, because one of you guys wanted to talk about E. Let's see what E wants. You are fighting a monster. So I will read E because one of you wants it to be discussed. That's completely okay. I think it's good if we discuss this problem as well and see the solution. So let's talk about this problem as well. It says that you are fighting a monster with Z health using a weapon with D damage. Initially D is equal to 0. You can perform the following operation. Increase the damage of your weapon by 1, costing X coins. Attack the monster dealing D damage and costing Y coins. Increase the okay. You cannot perform the first operation for more than K times in a row. Find the minimum number of coins needed to defeat the monster by dealing at least Z damage. Okay, so you want to deal Z damage, and each time you can either increase D by 1, initial D is 0, or attack the monster. Okay. Well, first of all, what comes to my mind is that if I understood the problem correctly, I'm not sure if I understood it completely correctly, but it seems easy. I mean, first of all, I think you need to first increase your damages as you can, and then attack the monster. I mean, you will never attack the monster first and then increase D. That doesn't make sense, because by swapping these two operations, you get a better answer, I think. So let's bring a solution as well, bring a code as well, to see how everyone have. Yeah, E seems, I agree, exactly. Seems very easy at first glance. Exactly. But I'm not sure what I didn't understand, because it really looks okay. Based on what I see, do you agree that it's always better to first it's always better to first try to increase and then damage? Because if you damage and then increase, you could swap these two operations and it's gonna be better for you. I think it's mostly an algebra thing. I mean, uh, I think you have to, I mean, using algebra, it can be solved if it's only this. Oh, shit. Yeah. Yeah, you're right. The constraint was about doing the operations in a row. Yeah, it's just making the algebra parts a bit harder, because you need to increase and then one damage and then increase and then one damage and then increase and then one damage, and after some time only damage. It's just harming you. I mean, I don't like this type of problems that much, but it's just harming you. So maybe you can use a binary search or something to find out, or using algebra you can maybe instantly find the answer as well. I think, yeah. I think binary search should work. Let me take a look at some codes. Let's see if anyone has used binary search. Yes, some people have used binary search. I see some of the codes, and it seems some of the people have used binary search. So it seems still easy but harming. It's a bit annoying. I mean, do you agree that you still try to increase first as much as possible and then damage? But okay, because they cannot be in a row, in between them maybe once you need to do one damage and then K increase one damage, K increase one damage, and so on. So you just need to do this. We can, for example, binary search on how many times you want to increase and then do the damages. I mean, that's a very general thing. It mostly acts as a hint, mostly. It's not a complete solution, but this is what I got from this problem. Does it help? I think that it can help you guys. Does it help? Did you agree with what I said? Yeah, maybe attacking costs less than upgrading, but it still is true that you try to do the attacking at the end as much as possible. So you won't do an attack unless you have to. For example, you did K upgrades and now you want to do one attack. Then K upgrades, then one attack. But you don't do two attacks or an attack in between those K steps, because it's better if you keep it for the end. That's gonna be better. So I mean, you're gonna have a binary search on how many times you will increase. For example, I think this is what comes to my mind. I'm not sure about it, but I mean that seems very logical. You can, for example, binary search on the number of times that you can that you will increase, and then just see that what happens that way, how much damage you will have. And yeah, I mean, in order to have that damage, how many attacks do you need? So you will see that what is gonna be your cost at the end, and at the end it's not exactly binary search. It's gonna be ternary search, because there's gonna be some points that it's gonna have the minimum cost, and you can find that up, or you compare some x with x plus 1 and see which one is lower, and that's gonna be, I mean, if x plus 1 was better, you have to search in the right part. If x was better, you have to search in the left part. We can binary search on number 1 operation with limits 1 and z. And on number of times we will increase. My idea was on a binary search on how many times we will increase, and see that if we're gonna increase these many times, how many steps do we need to finish the monster, kill the monster? And I think that must be ternary searchable, and you can find the points that is gonna be minimum. and this way you can find the answer. Yes, what I'm saying is that, I mean, my observations, the observation is that if we're gonna ever increase, we would want to do it before attacking, as long as we can, as much as we can. We don't do attacking unless we have to do attacking. Because if we do an attacking that we could skip it, it was better if we could do it later. It's better if we do it later when we have more power, more damaging power. Doesn't make sense. It was not a complete solution. I'm just telling you the observations. I hope that it can help you guys. So, does it work for you? Is it okay? Nice. Great. Great, you're welcome. My CF handler is God people. I'm stuck at a particular rating range. Pupil, please give some tips. As I said, the best possible tip is that there are no hacks. You need to try to solve as many problems as possible. Let me again, I always do this. I always show my own plots in the streams to tell you about what I did myself. Even if you watch the previous stream, you will see that as well. But if you join this stream, let me show it again. So if you look at it, I was a newbie at some point, and then in around 3 or 4 months, I got rank 4 in a Div 2 contest. I had a massive increase. If you ask me what I did, I think that I was solving more than 10 problems a day in Codeforces. And my strategy was that when I was stuck and I had no further ideas on a problem, I was reading what people do. I was reading people's code, not editorial. This is my strategy. This is what I did. And I think that it was very helpful for me. I do not believe that if you are stuck at the problem and you really have no idea, you should keep thinking about it forever. No, I mean, I think that's not very cost efficient. I mean, you have some limited time, and you have to keep the efficiency of your time that you're spending. So the point is that if you're really stuck on a problem and you have no idea, you can then take a look at this problem. But the main thing is that as long as you have an idea, do not spoil them. If you have a hope that you can solve the problem, if you have some ideas to think about, to test, it's good to try to think about them before going to read about the solution. So if you have some ideas still, try to continue thinking about the problems, don't spoil them. The feeling of solving a problem is really great. I mean, it feels really good when you solve a problem. And I remember, it was really enjoyable. So as long as you can think about the problem and you have some hope that the problem can be solved, continue thinking on the problem. When you reach the point that it is that you really have no idea anymore, you don't know what you can do, then you can, for example, go over the tutorial and read, for example, the first line or more than that. If in the middle of reading the tutorial you reach some point that you still have, you then were thinking about new ideas, then close the tutorial and think again. And this approach would really help you. This would really help you to improve. I think that is gonna be one of the best things that you can do. Why no topic streams this Friday? That's a very good question. The reason was that there were several contests in a row, and that was a bit problematic that we had these many streams right next to each other. So I wanted to put it in a time that is less crowded. With high probability, I will put it on Wednesday. So tomorrow we have another contest to be covered, and then on Wednesday, I hope we're gonna have the next topic stream. The topics are all prepared for the topic stream, and the vote is on Telegram channel right now. You can vote which topic you want to be discussed, and we're gonna have the topic stream this week. Ternary research was that my intuition was that the minimum cost is gonna be in the middle. I mean, there is gonna be some increasing, some number of increasings that if you had that many increasings, that your answer is gonna be optimal. Please stream after every contest for discussion because information which you provide is very much. I'm so happy to hear that. I mean, that means a lot. Thank you very much. Thank you very much. I'm so happy that it's helping you, and let me know if there's anything else that I can add to this stream to make it even better than what it is right now. And but also, I mean, I try to make sure that any stream that happens on the channel is gonna have the best possible quality. So don't worry about it. We will try to make all the streams as good as possible. Would it make any difference if we didn't do the increasing at once? Increasing, I mean, we try to make the increasing, I mean, what to do if we didn't do the increasing at once? Because if you mean about that last problem E, the point was that in the middle of increasing, it's not very logical to do the attack, because we can wait first to increase and then do the attacks. That would be better. So should we hide problem tags or not? Yes, at the beginning it's better. I mean, if you're learning a tag just recently, it's okay to solve problems from that tag. And thank you guys very much for all the emojis. If at the beginning you're doing you're learning a topic, for example, you're learning dynamic programming, you want to solve so many dynamic problems, that's okay. But over time, when you are just, sometimes you need to solve tag-free problems that you don't know their tag. They can be from any tag. So I mean, at the beginning it's okay if you solve with tags. For example, you want to learn a specific topic, you're gonna train for dynamic programming. You're gonna solve so many dynamic problems, you sort the problems, or in the Codeforces, you filter their problems by their tag of dynamic programming and start solving them. But over time, when you got better, you're gonna need to start more tag-free problems and solve problems from different tags. And then it's better to hide problem tags, because problem tag itself is a hint. You can treat problem tag itself as a hint. If you wanted the hint, you can turn on the tag and see that what was the tag. So problem tag itself, when you are trying to solve a tag-free problem itself, is a hint. Thank you very much. I'm so happy that you like these streams. That means a lot. I hope that in the topic streams can be really helpful as well. I really want to help as many people as possible. So even if you know other people who who might need these topic streams, let me know. I want to do something that together we make better topic streams that can help a lot of more people. So let me know that's what we can change, how we can make it better. That's the reason why I ask you guys that what topics you want me to cover, because I want to really see that's what you guys need the most and what's gonna have the most effect. So together, I hope that we can make this topic streams as good as possible so that it can really cover all the important topics for everyone. If you know anyone else who might get benefits from those topic streams, definitely invite them as well. I would be definitely way happier if more and more people will join there, because it makes the work way more meaningful. I can't even solve 900 rated now, and I am at 600. That's okay. That's okay. I mean, at the beginning that happens. You need to practice more. I mean, CP don't expect to achieve things very fast. You have to continue working on everything, and you can achieve very fast. I think I missed this. 10 problems a day means more than 10 hours a day. No, not more than 10 hours. It was maybe 5 hours. I mean, it depends on the difficulty that you choose. The difficulty was in a range that it was taking 5 hours per day, for example, for me. I wasn't solving so hard problems. I mean, you need to also adjust the difficulty of the problems. For example, if your rating is low, back then in this situation, my rating was low. So I was solving problems. I was solving very easy problems. I mean, problems like A and B, and that really helped me to increase my rating a lot. How do you practice work that problem for? Yeah, I think I answered it right now. I mean, when I started, in that one, I was mostly trying to solve A and B's. Yeah, maybe I can organize some contests as well. If you guys want, we can organize some contests too. when my rating was low, I was using rating wise. I was solving problems with low rating. Thank you very much, guys. Love from Iran or the States. I don't know from where I should send love, but thank you a lot. I'm sending you love as well. Where are you guys from? Yeah, I can do that. Yeah. India. I yeah, when I solve it with greedy, I think about the proof as well, because if you don't know the proof, it's possible that you get a wrong answer and then you don't know if you have a bug or your solution is wrong, your greedy solution is wrong. So it's definitely good if you need to know the proof. Only in rare cases, for example, when there's no time left or you have no other idea and you just want to test out if maybe it works, in those cases, maybe in very special occasions in a contest you solve it, you accept it without having a proof. When, for example, there's not much time left and you want to test, you hope that it gets accepted. But usually you need to have a proof. Because otherwise it's worse for you. Maybe you get a wrong answer and you don't know if you have a bug or your solution is wrong. US. Rating wise or topic wise? Yeah, as I said when I started, I was more solving rating wise. I think I answered this before for another question. Thank you guys. Thank you again for joining today. I hope you enjoyed this topic stream. That it wasn't a topic stream, it was a solution discussion. Topic stream is gonna be this week, and we're gonna continue talking about the topics. And congrats for becoming 1700. I hope that soon you will get 2700. See you guys in the next solution discussion tomorrow, and then after that in our next topic stream. Thank you very much for joining today. See you guys. Bye.